the session on the electrification of the auto industry. So yes, so my name is Vikram. So I'll first start with my quick introduction. So I've been a product into product and smart mobility as well as the intelligent transportation systems. And lately, as you see, the industry has now ventured into e-mobility. So I've also started, designing as well as working on the electric vehicles. So just to give a brief outline of how my journey was before we start into it. So I graduated from IIT in 2008, and from 2009 to 14, I worked as a developer in startups, and I was mostly building into digital products which are very scalable and secure for the people to use. And then from 2014 to 16, I started building as well as managing the B2C products, mostly in the online domain, as well as on the computer software products. 2016, I started, working on the smart mobility solutions. So what do you mean by smart mobility is anything that helps you to move from one point to another point in a very smarter way. And that is how we define as a smart mobility. So it has been a huge improvement on the smart mobility, helping people to do or move as a faster and a more both a better managed way. So that is how the smart mobility is all about. In 2021, I switched to the EVs. I started working with Ola Electric as a senior product manager, building their flagship scooters that you all know is there in the market for at least almost 10 months now in the market. And in 2022, I completed my MBA from Indian School of Business. And I'm continuing to work in the automotive industry and building the EV ecosystem in some way or the other. In between, if you have any question, please let me know. I will not be able to have the view on things, so I will. If you can raise your hands, I maybe take that as a feedback and move on. Okay, so now let's understand how the automotive industry has moved so far from the beginning. In the World War I time frame. After that, how the industry has moved. So predominantly, it is a fossil fuel industry. It has been the two-wheeler, three-wheeler, four-wheeler, the commercial vehicles, everything. They're mostly dominated by the fossil fuel-based vehicles over the last, I think, whatever time we can see or we can remember or we can see in the history. So you see that this is a very nice chart which explains how the countries have moved over the years. So initially, from the very beginning, US, you see the US is in blue. So US has been leading from the very beginning in the 1950s, and it has been growing. But the share of the automotive manufacturing in terms of the country has already been declining over the years. So you see on the top, the China is actually been dominating in the recent years. And also you see the India share is also increasing. And it is a matter of fact, in 2018, India has overtaken Germany as the fourth largest automobile producer. So this is how the overall scenario for the last, I think, 75 years has been in this industry. And this is predominantly is fossil fuel dominated industry, and it is before the EVs and all these things come in the very recent times. Okay, so talking about the top 15 automobile manufacturers, so this is the 2017 data. So you see that Volkswagen and Toyota are already on the top. So sometimes Volkswagen becomes in the top. Sometimes Toyota becomes number one, and that is how they're dominated by it. Volkswagen is obviously from the German group, and it is mostly a European company, and Toyota is of course a Japanese company. So, and you see all the other players are there, and this doesn't include Tesla and other EVs that has come lately in the market, and this is the 2017 data by the OICA. And you see the numbers of production in million units. You see there is a drop in 2019, and still steadily it is going up and up and up. Then coming to the main components of the vehicle. So I think most of us attending this, we know what are the automobile components are. Just to revisit, what are the things that we have? So is the car engine. Car engine is the most important part of the vehicle because that gives you the power, and it uses the gasoline and it just converts that into a mechanical energy, and the entire vehicle, the other things that are there, are just uses that energy to move you from one point to another, even including the converting that to electricity, which saves, which runs your ACs and other accessories that are there on the vehicle. And then you have the chassis. The chassis is the main structure of the vehicle. You might see the some of the new structures coming up, like flatbed. If you go and buy Tata Motors vehicles, you see that they talk about alpha structures and all. So they are just the platform on which the chassis is built and the vehicles are overall has been built. And there is a transmission system. You have the clutch, the gearbox, the differential, and the axle. This, I think, you pretty much understand what they are. And the body. So the control systems are there, the steering system, the braking system, all these things are there. And then there are auxiliaries. So auxiliaries like indicators, ACs, fog lamps. There are many auxiliaries that you can talk about. And over the years, all these 5 components have evolved in a much better way. So you see the car engine has become more powerful, and it has become more efficient in that way from the IC standpoint. Chassis has become the global safety standards on the crash. So they have become the global tests that have been done, and you give 4-star, 5-star, 3-star ratings in the vehicles. The transmission systems has become much more efficient. You can have more load it can carry for the commercial vehicles. The body has also become more digitized. Okay, so the control systems and all have become more from the analog system, it has become more digital in that way, and the implications of semiconductor has come into that picture. Auxiliaries, the indicators, AC indicators has become more on the LED front to save the energy and everything. So all in all, these are the main 5 components that is there, and all the job you have that related to somewhere or the other. You will find some people working on car engine, which is one of the most critical component of it. Some people work on chassis, some people working on body and the subsequent things and the auxiliaries. So just imagine these are the situation in the pre EV era. Okay, and just now think, and I'll give you an idea, like car engine gives you a lot of job in the market. Okay, there are a lot of people who does design engines, work on the efficiency of the engines, and they work on the lubricants, they work on some of the design of this crankshaft, gasket, and all these things. And also there are subsequent industries like who supply a lot of components for that. Just imagine all these things have been removed by a simple motor. Okay, what will happen to those jobs? They're all gone, and there is nothing like you can rework on this gasket and piston and all these things on a motor. No, there is nothing. So this transformation is happening. Okay, and this transformation is happening for the last couple of years, and it is a truth today that the EVs are more and more predominantly, and the future is of course electric. Let me go and give you some more idea on that. So what are the tasks people used to do in the pre-EV area? So if you talk about the task and the background and the skills, it is a very simple mapping. So people's job is to design, develop, and manufacture vehicles, improve any mechanism related to the vehicle, and do the testing and validation. And that is how the way manufactures the vehicle and produces the vehicle and get it to the market. So from the background, you have the bachelor's, master, or PhD in mechanical, automotive, or electrical engineering, who does all the design and development of that. And then you have a host of downstream companies who supplies your parts, and you assemble the vehicle and deliver it to the customer and do all the things of like sales, service, and after sales experience and everything onto that. On the technical know-how side, predominantly it is automotive companies need the people who are the engineering and from the system design perspective, so that they can make the vehicle and they can market the vehicle, and that is how the overall automotive experience in that way mattered. Okay, now let me tell you a little bit about why automotive future is electric. Okay, so I'll tell you a couple of things on this. So first and foremost is the pollution. Okay, so the major causes of air pollution that if you see on this particular if you see on the, just give me a moment, let me see if I can get the, yeah. So if you see this the center center image, you see the major contribution of the pollution is the automobiles or the transportation industry. Okay, and people have been thinking why there is a need to change to electric. Why can't the traditional, what we call as the IC engines can work, and they're already has a stable industry, stable supply chain. A lot of people are working, their livelihoods are dependent on it. But it's now people are getting more and more concerned about this climate change, and transportation is one of the major reasons of the pollution. And so people are thinking whether we can minimize that. So when you go to a city, you see that whenever you are in the center or where the traffic is very high, the air is very polluted because the NOx emissions from the automobiles or the transportation industry is very high. And that is why the government wants that you to switch to cleaner mobility, which will have lesser implications on the environment and overall on the earth. Okay, so because of that, there are four things that has mainly dominated, if you look at the industry as holistically. uh, Regulation. So government has now started to invest on the newer set of technologies so that we can migrate. And the consumer behavior are also changing. Consumer wants a better vehicle which can run very fast, which has all the capabilities. And of course the technology is evolving, so new technologies in terms of the EV technologies has come, and they're of course very efficient in terms of the system. So efficiency, I'll come again. This is one of the major drivers why EVs are like far ahead of any other systems that you have in terms of transportation. I'll come to you. Before that, let me also highlight that what are the skill sets you have, so which is going to change. So if you see the European market, this is 216 billion euros. This is from 2019 and 2030. You see that 26% is still the engine systems, transmission, fuel injections, and 48% is the stable components like structure parts, AC systems. But if you see the growth of it, so 26% was the hybrid systems, battery management, and they're shooting up to 52%. So there is a lot of jobs will be created in this particular area. And you can see that these are the sunset industries. So the engine system transmissions will come down over the time. And there is a huge loss of livelihood in this particular section, and also some part on the middle section as well, because these are all getting streamlined, these are all getting digitized in some way or the other. It is getting improved. And the people who are working on the interior sensors, specifically battery management system, motors, they're going to gain in a huge way. Yeah, so you see that market sizing in 2022 it was 8.5 thousand, and in 2030 it will become 39 million units globally, which are having a CAGR of 22%. It's a huge amount of vehicles that will come in. So you see that how the change is going to happen. You see the more IC vehicles are getting turned into the electric vehicles. People who didn't afford electric or didn't afford or didn't get vehicles, they're also going to buy the EVs. And so the market is going to switch from one end to the another end. So I'll talk about the energy part, why I talk about efficiency, why it is so good. Okay. So first thing that you have to understand is whenever I have a gasoline powers, gasoline is basically petrol, and there is diesel. So gasoline and diesel. So if you go to US, you will see that you will have gasoline and you will have diesel. So in India, we use petrol as a more common word for fuel, but gasoline is what petrol is. So if you talk about IC vehicles, which is like a petrol or a diesel vehicle, 80% of the energy is lost through various inefficiencies. So basically, if you give 100 calories of total energy to that vehicle, you actually use 20% of that, and the rest of the things are dissipated. Okay, there are engine losses, other losses, drivetrain losses, auxiliary use. Okay, so only 16 to 25% energy goes onto the wheels, and that is what it drives. So you imagine how much inefficient the system is. When you talk about electric vehicles, so if you talk about the amount of energy that you give, it just wastes around 11% of the energy. So mostly more than 80% of the energy is actually being used. Okay, so if you look at the image, so You talk about in US daily consumption in 8.9 million barrels per day to run the IC fuels. When you replace this gasoline with coal, like you are getting a coal-fired plant which is producing energy, so it comes down to 6.1. And if you replace this gasoline with 4.6 million barrels of gasoline equivalent with a natural gas, it comes even down to 4.6. So you can imagine how efficient the system becomes. So if a car is running on electricity which has been produced by a hydropower, that is the most efficient system the world can ever produce. But in general, if you still use a coal-fired plants, you still are using a more efficient vehicle, which is like losing out around 11-12% of the energy, and rest all is getting translated into the motion. So you actually need lesser energy to run the fuel. So I have a small video which I want you to go through just for a couple of minutes to understand just a comparative understanding of, does it actually mean that the electric vehicles pollute more because you need lithium and lithium needs to be mined on things. So just let me show you this video quickly. So I just want to reshare it because this has a I hope you can see.
So the argument goes, electric vehicles don't pollute, but the electricity powering the electric vehicles does pollute. Some even say it pollutes even more than a gasoline or petrol burning car. If we're going to look beyond the EV itself to the energy that powers it, shouldn't we do the same for the fossil-fueled combustion car? So what goes into producing the fuel that you burn in your car every day? Gasoline or petrol starts as oil, on average 5,900 feet below the surface of the earth. A great deal of oil is extracted using what is called a pump jack. Pump jacks don't run by themselves. In most cases, they use electricity. It takes, on average, 9,960 kilowatt hours of electricity every month to drive one pump jack. To put that in context, that is enough electricity to power a Tesla Model 3 for 34,860 miles. In the United States, there are an estimated 435,000 oil wells using pump jacks. Estimated electricity use for these wells is over 4,300 gigawatt hours a month. That is a lot of electricity, and that is just to get the oil out of the ground. If we used that electricity to power electric vehicles directly, it would be enough to power over 15 million electric vehicles for a month. That's just US oil wells on land. What about deep sea drilling? The most common way of powering an offshore oil rig is with a diesel generator. An average oil rig generator uses 20 to 30 metric tons of diesel per day. The electrical equivalent to this is 300,000 kilowatt hours. There are an estimated 1,470 offshore oil rigs in the world using over 1.3 billion kilowatt hours of energy a month. All this oil pumping combined would be enough to power 19.5 million electric vehicles per month. This is just from the energy used to pump the oil out of the ground in the US and offshore. So not only does the fuel pollute when we burn it in our cars, we are also using a huge amount of electricity just to pump the oil that makes the fuel. Combining the pollution from the tailpipe emissions with the emissions generated to pump the oil out of the ground is not a pretty picture. And pumping oil is not clean. Millions of gallons are spilled into the ocean every year, causing havoc for fish and other wildlife. Then that oil needs to be transported. Most of the oil is pumped through pipelines. There are over 337,000 miles of pipeline in the world, carrying most of the 100 million barrels a day we consume. These pipelines use pump stations that use even more energy. Oil is also shipped. The oceans are unregulated as regards emissions, so ships use the cheapest, dirtiest fuel possible to keep costs down, making them one of the largest pollution sources on the planet. Shipping is responsible for an estimated 1 billion tons of CO2 per year, and 10% of that is shipping oil. Because these tanker ships pollute so much, many countries do not allow them to operate near their coastline, so they have to be towed into port where the oil is transferred to a refinery. Refining oil takes a huge amount of energy and generates even more pollution. Refining is done by heating oil up to 800 degrees Fahrenheit or 420 degrees centigrade. Heating 100 million barrels of oil a day to these temperatures requires an enormous amount of energy. Heating this oil generates so much pollution, refineries create a serious health hazard anywhere they operate. Refineries are the #1 pollution source in many major cities around the world. It is so bad that people living near these refineries have a marked increase of lung disease. Once the oil has been refined, it is transported to fuel stations in diesel trucks, creating even more pollution. Then this fuel is burned in cars and trucks, right in our cities where we live and breathe. These cars and trucks have internal combustion engines that are extremely inefficient. 70% of the energy from burning fossil fuels is wasted as heat, while only 30% goes to turn your wheels. So after we use all that electricity pumping oil out of the ground, refining it, transporting it, we then waste 70% when we burn it. Fossil fuel production is an incredibly dirty, inefficient process from start to finish. When we contrast all this to powering an electric vehicle, the difference is very stark. Electricity does not need to be pumped from thousands of feet underground, transported with trucks or trains, or pumped along pipelines. It does not need to be shipped overseas. It does not need to be refined, and it is not polluting where we live and breathe. Even if electricity is produced from burning coal, the power plant is far away from population centres, transferred over power lines, keeping any direct pollution away from the population. And if the EV is powered with clean energy, it is clean from start to finish. In the United States, 47% of electricity comes from sources that emit no CO2. In Europe, it is even better at 56%. And the percentage of clean energy is growing every year as coal and gas plants are being replaced by renewable energy sources. So what about the lithium used in EV batteries? Lithium is a metal that is mined in the deserts of Australia, China, Argentina and Chile. Besides being a key ingredient in batteries, lithium is also ingested as a medicine for bipolar disorder. Much has been made about the environmental impact of lithium mining, but this is all a little bit overblown. Australia is the largest producer of lithium in the world. If there were any major environmental problems with this mining, some Australians would be talking about it. But what is Australia really talking about when it comes to pollution? Oil refining. Yes, oil refining is creating a much bigger environmental risk than all the lithium mining going on anywhere in the country. Australia is not a very densely populated country. They consume 1% of the world's oil supply and only refine 1/4 of the oil they consume. But they mine 50% of the world's lithium. So a country that only refines 1/4 of 1% of the world's oil and mines 50% of the world's lithium, the biggest contributor to pollution and risk to human health in Australia is oil refineries. That does not even take into consideration the drilling, pumping, transporting and burning of this oil. This is just refining it. The more you look into it, the argument that battery production is somehow as bad as the cycle of fossil fuels is ridiculous. All the lithium mining in the world to date has not done anything like as much damage to the environment as just one major oil spill. So, what about the batteries? What happens to EV batteries when they get old and are discarded? When no longer practical in an electric vehicle, the batteries can be used as energy storage to power a home or business, giving them a second life. And when they're no longer any good for this, they are recycled, broken down.
I think you have got a very fair enough idea that the batteries, the EV batteries are not that polluting in nature, and it doesn't take much harm to mine it. So there is a scarcity of lithium, but over the time when the recycling becomes a mainstream thing and the batteries that are getting into the vehicles get replaced, so we will have more, lithium will get recycled. So that is how the things are. Now coming to the electric vehicle, the vehicle electrification technology. So you have three kind of electrification that is there. So this is the older one, the gasoline, or the the earlier one that we used to have. So you have a gas or a gasoline, and you have electric, the electric sorry, the gasoline engine is there, and then it has a motor, and that drives some of the things. So the electric motor is given to have a regenerative energy back into the battery system. So that is how it's a fuel powered vehicle, and currently the majority of the vehicles are running this. Now they are calling a plug-in hybrid. Okay, so in plug-in hybrid, so there is a dual option. So there is a gas and there is a battery. You can charge the battery, you can put some gas in it. So both the things can be used, and you will never have the anxiety of going out of range, or the battery getting discharged. So this is one way a good solution. But why it is not so popular? Because the cost of manufacturing such vehicles are very high, because you need to put both the electric motor and the IC system into it, and it makes it very very complicated in general. And now you have only the battery electric vehicles. You have a battery, you have electric motor, and you charge the battery and run the motor, and the vehicle runs in the market. Okay, so this is how battery electric vehicles are in general. You have, so the battery size becomes from 20 kilowatt hour to 80 kilowatt hour, depending on what type of vehicle you are purchasing. And this is what we mean by electrification. So more and more, the source of the fuel and the components that use the fuel is being replaced by a simple architecture, which will have a battery and a motor. And the motor is one of the most stable solutions that we have in the earth till now. Okay, the motor has also evolved over the time, but right now whatever we have in terms of the stability of the motors technology, it is very stable in general. It is a battery which is evolving over time. It is becoming more and more efficient, more and more getting fast charging capabilities, and that is how this is moving in general. So I'll tell you the most important concepts of the motor. So there are 4 or 5 kind of motors that we see. So one is brushless DC motor, the BLDC motor. So you might be seeing that some of the electronic companies are also selling fans with BLDC motors. BLDC motors doesn't have any much sound compared to the other motors. It's very silent, and it is very lightweight. So for two-wheeler and three-wheeler, BLDC motors are the most suitable in general. And then the second one is a permanent magnet synchronous motor. This is one of the most famous thing for four-wheelers. So if you look at the electric cars, like you have in India, the most popular Nexon EV. So Nexon EV uses the permanent magnet synchronous motor. So this is a new technology. It is even better in terms of that. Apart from that, there are AC induction motor, interior permanent motor, and a permanent magnet switch reluctance motor. So these are used in four-wheeler. It depends on the technology that the company wants to adopt. But these are all the options that is there in general in the electric vehicles. And this powers the main energy. One more thing about these motors, these are traction motors. Okay, so there is a difference between the motor that runs on your pump and pumps the water to your tank, and this traction motor. So traction motors can be increased or decreased. The speed can be increased or decreased based on the electricity that you power. So you cannot bring your pump motor and say that I will reduce the electricity and the power of the motor, the rotation of the motor will go less. No, it doesn't happen. It will stop. Okay, but on the other side, the traction motor is more driven by semiconductors. So the variation of the current actually, pushes the motor to move faster and slower based on whatever is the electricity that is, as per the specifications of the motor. So that is why they call traction motors. So that's why whenever you buy a EV two-wheeler and you put the accelerator, it just zooms. Why? Because the more current is being supplied, and the controller gives more power to the motor, and it just zooms with the speed. So, so what are the main components of the EV that is there? So right now you have seen the IC components which interact with each other. I told about in the very beginning that there are engines, there are chassis, there are body systems, and then there are the peripherals and auxiliaries that we have. From there, what we have moved down is a very simple architecture. So just remove the engine from there, and all the engine related components because there is no fuel. So that is being replaced by motor. So that has been replaced by battery, and you have a motor instead of the engine. And rest of the things like the powertrain, how the power is getting distributed from that motor to all the four wheels, they are pretty much have stayed similar. So that's why you will see some of the companies have launched, let's say, converted their IC vehicles to a electric vehicle, and they are selling in the market. Okay, so some of the components you need to know, which will give you an idea that how the skills you would need to build over the time, or how you can refine your existing skills so that you become suitable for the EV industry that is coming up in a big way. So talking from the engineering perspectives, power electronics, motor drives, electric machines are the one of the most important thing, because people want to develop and design those internally. Right now, there are a lot of suppliers which supply the motors and the subsequent power electronics for them. Foxconn is one of the suppliers who makes iPhone. They also does a lot of electronics design and development for these automotive companies. So the advanced electromechanical powertrains, the system integration, how do you integrate the motor into a vehicle, and how to do the subsequent system integration and thermal management. Thermal management is the most important thing in the EVs, because lithium is very prone to fire, because because if you don't operate within the safe operating area, there are chances that it will burn. So thermal management is one of the most important part of the entire EV ecosystem. And people who come from come from the system integration, the electromechanical understanding of the electromechanical system, they can definitely get into the thermal management part of things. And then you have the vehicle controllers and electronic control units, which controls the unit. So I can give you one example, like motor controller is one of the controlling unit. You have the battery management system, you have the telematics control unit. So all these small ECUs are your one of the important things in the EVs. And then of course the battery and storage management system. So a lot of people who started learning the battery engineering and how to make batteries, which we call the advanced chemistry cells. So those are one of the most important things. So whoever is coming from a chemistry background and want to delve into the battery engineering, they can definitely get a lot of opportunities going forward. Sorry. So there are a lot of other components also, which is right now having little traction, but maybe gain more in coming days. Some of them like hybrid battery and ultra capacitor energy storage system. You have the fast charging capabilities, how to fast charge a lithium ion battery. So those things are like the emerging fields, which will stabilize in another 5 years or so. So those people who are just coming out of college, they can take up those systems. And of course, this standard vehicle to grid, vehicle to infrastructure, vehicle to home, all integrations are all will come over the years in that. But they're in a very, very nascent stage right now. Okay, so what are the challenges of this particular electrification that we see? Okay, so sorry. So one is the range anxiety that people usually have. What will happen if I buy an EV and let's say I'm going for 400 kilometers? I don't find a charging station. Even if I find a charging station that is out of service, what will happen to me? So this is the possible anxieties that people are having on the EV industry. If you are moving within city, that is less, but if you are going for long range drives, that is usually more. And then the battery issues are there. You have seen in India a couple of battery fires happening, people losing their lives, and it is government also has interfered that how to make the battery safer. Then obviously the second point is the challenges with the lithium ion supply. You seen in the video that Australia, Chile, some part of China, some in areas in Africa, they are the main source of lithium ion. So India is not a source of lithium ion. So you need to buy lithium from outside and then build the batteries. So again, that is a challenge for India. Charging infrastructure, yes, yeah, this is one of the most important thing. So it's an ecosystem. If you have more chargers, people will buy more EVs. If there are more EVs on road, there will be more charging. So it's like a cycle in itself. It's like similar to the the mobile phone ecosystem that you have. You buy Android because there are a lot of apps into it. You don't buy Windows because there are no apps in that, and developers also don't want to like because there is no users in that. So it's like that kind of ecosystem which is there, and people want to move out from that. And so slowly government is pushing. So we are sure that in another 5-7 years, the charging infrastructure will be quite good. The total cost of ownership is still high. The upfront for cost that making a EV is still high. So if you go to the market, you will be able to start buying a IC vehicles at 5 lakh. But if you go to a EV, it will maybe start from 9 lakhs around, or 8 lakhs around. So still the initial cost of ownership is high, though the running cost becomes very down. But eventually, it all depends on the monthly household income. So if the monthly household income is less, so if you have to pay a lot of money at the beginning, it still doesn't make sense for them to buy. And in EV, it is mostly a software dominated. So you have to have the semiconductor supply. If the semiconductor supply is not great, just like we had in last 2 years, again, the manufacturing and supply to the EVs to the market will be slower. So this is one of the things. Apart from that, I will just like to highlight. So there are a lot of fires in the market. So you see that why lithium catches fire. So I'll just tell you a very brief idea. So this is the voltage axis and this is the temperature axis. So let's say the lithium ion works fine till -20 degree and works fine till 55 degree. So this is the range on which you need to play. And 2.5 is the lowest discharge voltage, and 4.2 is in a state when it is fully charged. So essentially, everybody needs to play. This is the same operating area, and this is where the battery management system needs to work to make sure the battery always stays in this area. So if it goes beyond -20, there is a thermal system which heats up the battery to keep the temperature optimal level. If it goes beyond 55 degree, it has to reduce the usage of the battery so the temperature comes down, or you have to cool it with some other technologies like flowing the liquid, flowing any other air or something like that. Similarly, if a battery goes beyond 2.5 volt, below that, there is a chance of damage. If it goes beyond 4.2, there is also a chance of damage. So all these cases where the fire has happened, or the battery get discharged, or battery doesn't work anymore, they are either has reached one of the states. So that is why the job of the BMS is to make sure that whatever is the requirement, I'm able to manage the battery in such a way it is in the safe operating area. And that is the job of a BMS engineer or a BMS application engineer in general. Going forward, there is a lot of subject matter expertise for EV era. Okay, so I'll just give you very simple understanding of it. So you know the vehicle integration. I already talked about how to integrate the vehicle and system with battery, motor, and all. There is a EV design and engineering. So how do you design the overall EV and the engineering associated with it? All the mechanical systems that are associated on the vehicle, like how do you generate the energy from the motor and have the powertrain so that the energy drives the wheels. Other mechanical systems like the chassis, the what we call as the wheels, the suspension systems. All this comes under the mechanical systems in general. Simulation is something very important because you simulate and try to see whether this solution that you are proposing is working well or not. So there's a lot of computer simulation you need to do on MATLAB, on other systems that are available. So there's a lot of opportunity for that particular area. Of course, the electric motor technology is the most important. The people who are coming out as electrical engineers, they can start, get into the electric motor design, and that has a lot of opportunity because I talked about 39 million EVs that will apply, and some part of it in India. So there will be huge demand of motors and the maintenance of those motors. So there will be always very highly opportunity in the next 15 years for this kind of people to go and work. The next is the automotive testing and validation. So you know that any vehicle, when it comes to the market, first it goes through the trials and all the government certification. So there are a lot of field trials you need to do to find out whatever you are trying to build is that matching with that, and then only when it passes. So this kind of work that for the testing and validation is also a very huge opportunity for people. And software development is also, as you know, that more and more vehicle components have been driven by software. So of course, more and more software engineers will be needed to manage this. And the EE architecture. So EE architecture is basically called the electric and electronics architecture. So how the internal components are wired, how they are working, how the control systems work with each other. So this entire architecture is now evolving. and we will have more software dominated architecture and semiconductor dominated architecture going forward. So is the opportunities control systems, of course, the MCU, BMS, and all the subsequent subsystems will come into that. And yeah, one of the new and entrant into the entire set of things is the AI and ML. So artificial intelligence is coming into that. Machine learning is coming into the way systems have been designed. I can give you a small example that when you ride your EVs for some times and you are riding at a very high speed, the range automatically comes down because the battery management system learns how to calculate your range as per your driving behavior. Okay, so there is a lot of machine learning computation goes on inside the system to understand how you are driving and give the range out of it. And then the vehicle protocols are there. Earlier, they were used to use CAN. That has now evolved to Ethernet. If you go to the modern vehicles, they are all trying to improve that system and make it more efficient. And last but not the least is the cell engineering and the vehicle management system. There will be a lot of opportunity, at least for the next 15 years, to make the cells. And government is also trying to build the cell engineering capacity and as well as the capability in India. So those people who want to get into cell engineering, they can also uh, invest their time and energy into building that capability. And of course, there are a lot of opportunities in the coming time. The autonomous vehicle is very early stage right now, but still people are trying to build some kind of some kind of autonomous or some kind of help, we call about helping the drivers to improve their driving. But in India or the Asian setup, the autonomous vehicle is still far away from that. Maybe another 10-15 years we will have some stable technology to have the autonomous vehicle design. So now components and how do skills manage. So that is how I'm trying to do the mapping. So you see the battery technology is now coming to advanced chemistry cell design and testing of the battery. The motor and controller design have the electronic design, motor technology design, as well as the software design and development, because motor controller always has a embedded software which runs which has the logic written into it. Then you have the E architecture, the electronic design, the power electronics, RF system. So now you see all the vehicles come with all the antennas. Like now the 4G was there, now 5G is coming up. It has all the other systems like Bluetooth, Wi-Fi, and all the other RF systems like GPS antenna and other things. So it's a similar kind of things that you have on your mobile. So all the vehicles are getting with high quality systems. So there are a lot of opportunity. PCB design engineering is one of the most important because you need to ultimately design the PCB and then go for the production. System modeling is very important. You need to model the BMS MCU systems and then see how you are going forward. Starting from there, for the simulation, for the charging, you have power electronics, hardware design, inverter design. So now the DC-DC converter is most important because from one energy source, the energy is getting converted to another energy in the same DC. So the DC-DC inverter is most important. The BMS application, the BMS has to be designed and done a simulation to see whether it works fine. So that is one of the most important area. Vehicle software, again, the embedded software, C, C++, middleware, Android, automotive grade Linux, Qt are one of the most wanted skills right now in the market. And of course, in the software engineering, you have AWS, Azure, DevOps, system architect, and all these things, they are very important. And of course, product and consumer experience has now evolved. So you see product management, customer journey, user experience have been now thought through in a better way, and you get a better experience out of the overall vehicle. And then in the predictive side, you have the AI, ML, and analytics, which help you to build a lot of smart features, predictive things, and which helps you to build such features. So this is more or less the skills and the component mapping that is going on in the EV industry. So this is how I wanted to see that opportunity is coming up for you. Any questions? So I think now I am coming to the end of the slide. We can pick up the question as you have, and we can answer those questions in general.
Guys, anyone is having a question? Please ask. Please unmute yourself and ask. So I have a question, sir.
Yes,
So
please. Your name first, and then you can.
yes, sir. I'm Sindhuras. I'm from the training team, Skill Desire.
Okay.
So my question is like, what are the opportunities in India, sir? Like in the designing side, like since many of the EV industries are either from Japanese or German or other European countries are there. So in the designing side, what are we having in India?
So, to answer to that question, there are a lot of opportunities coming up for all the skills that I mentioned at the last slide. Okay, so people are Indian setup. You will see that Indian automakers are far ahead in terms of the Western automakers or Japanese automakers. So, if you look at the companies like the EV two-wheeler side, you will find a lot of great companies to work for on the design and development. Who does the design from the scratch, like Ola, Ather, you have Okinawa, you have Ampere, so they are leading the market. You have TVS and as well as the Hero Motocorp coming into the picture. On the three-wheeler side, you have a lot of players coming into the market. Mahindra is there. Then there are a lot of startups making things. So in terms of the opportunity is huge in terms of the design. So if you go by the mechanical side of things, there are a huge opportunity because you need to do and build and integrate the system. If you go from the software perspective, there are a lot of opportunity in terms of the the embedded software that people are building in the EVs or in the what kind of EVs that you want to build, two-wheeler, three-wheeler, four-wheeler. Everywhere there is a huge amount of software engineering being done. And in terms of the core things like the battery and the motor, I think the battery design, the BMS design, the motor design, there is a lot of opportunities that people are having, right now. And I can see that uptick is going to, become the skills is going to become so important that people will run out of people at some point of time because the industry is going so fast. So in India, the government target is 30% of the vehicles sold to be EVs in 2030. So right now it is only 5%. Okay. And it is like a very less numbers right now. So as and when it is scales up, you will have a lot of opportunity coming.
I see. Okay, so there's
Okay.
another question from
Ah,
Dishang.
yeah.
Are you able to see, sir?
Yeah, I am able to hear you. Please go ahead.
Yes, sir. There's a question from Dishang. Is
Hmm.
there any opportunity for the people who want to start a new automobile vehicle company or who wants to build electric cars or hybrid cars?
Yes. So in India, I'll tell you the story in India. India is predominantly a three-wheeler and a two-wheeler market. The first EVs that came to India is the e-rickshaws that you see on the road. Okay. Now tell me who manufactures the most number of e-rickshaws in the market? You don't have a ready answer because you don't know. So it is like e-rickshaws can be manufactured in small cities, small towns. Okay, because the architecture is very simple. You have a motor, you have a controller, you have a battery. so so think from that perspective. If you want to start a company, it's not very difficult. The analogy is that in a IC vehicle you have 2000 moving parts. Okay, when you come about EVs, there are only 200 moving parts. So this actually translates from the technology has become more available and simple. So if you want to start a company, there is no better time to start right now. Okay, because people are trying to buy more EVs, looking for more options, and you have the technology available, and it's not something that you need to build something out of the reinvent something and then start manufacturing. You can still get the component source and you can design the vehicle, assemble the components, and then do the testing and validation and launch it to the market. So it's possible to do at this point. And that is why you will see a lot of companies are now coming to make vehicles. Did you see uh, 5 years back how many two-wheeler makers were in India, and just see how many two-wheeler makers are there in India? Same comparison you can do for three-wheeler as well. You will get the answer in itself that it is not a rocket science that we are trying to build. It's all doable, and the technology is more and more stable, and you will be able to access that. I hope it is able to answer your question.
Yes, and sir, one more question.
Yeah.
Sir, what is the main factor which affects any car manufacturer? Like, is it a design or technology or a motor, or I'm specifically talking about electric cars, or it is a range which provides which is provided by an electric car?
So in general, I'll tell you something. So in any vehicle people buy in the market, there are a couple of points because of which people buy that car, okay, or the vehicle, okay. So one thing, there are a couple of things. So one is the running cost economics, how much it makes to run that vehicle, what is called a total cost of ownership, the attractive capital cost, like what is the cost that you pay to buy that vehicle, uh, what is the longevity of the vehicle, like how long it can run and how long it can give you that economy that you are looking for, better than peer resale value, like if you want to sell that vehicle in the market, you get some value out of it, and and the design features that it has. So these are the primarily the important points that for any person who looks into automobile looks for these particular points. So if you talk about whether people are looking for range and all, it all depends on the segment that you want to try for. If you want to try for a city rider sort of thing, obviously the maximum range people are looking for is around 100 kilometers or even less than that. And even the maximum speed is within 50 kilometers per hour. If you are looking for a different segment, which is like one thrill and one more features,
Seat cover
uh,
ನೆನ್ಕೊಂಡು seat cover
yeah. So for them, it is like a different use case altogether. So you might
ಸ್ವಲ್ಪ
need a,
ಡ್ಯಾಮೇಜ್ ಆಗಿದೆ.
can you mute?
ಯಾರು ನೋಡೋದಾರ ಕವರ್ ಕವರ್ ಯಾರು ನೋಡಲ್ಪ ಅದೇ ಯಾರಾದ್ರೂ ಬಂದು ಕುತ್ಕೋತಾರಲ್ಲ ನೀ ಅಲ್ಪ ಹೌದಾ ಅದೇ ನಿನ್ಗೋಸ್ಕರ ಹೇಳ್ತಾ ಇರೋದು.
Okay. So it all depends on the particular field. Sorry, it's a segment that you are looking for, and it depends on that segment particularly. So it's not only range and speed; it is a combination of maybe design, speed, range, and all these things based on what the consumers are looking for in that segment. Does that clarify your question?
Yes, for sure. Thanks.
So there's another question by Pritesh.
Hmm.
How can a just passed out student gain knowledge about TV? What course would you suggest for a student to make him
Yeah.
or her prepare
So
for the EV world jobs?
yeah, so what you want to do is what is more important than how you want to get into there. So let's say you come from a mechanical, from engineering background, you can you can look for whether you want to go in the electronics set of things, electrical and electronic sort of things. You want to go for the mechanical set of things. If you are coming from a non-tech background, you can take up the operations, sales, service, those kind of opportunities. There are ample opportunities. Like if you're a non-technical person, you do a MBA and you do a you do some kind of management education. You can get opportunities to work on these companies, and think about how you can build those capabilities rather than what course you will do. So course comes later, capability comes first. So first you need to think what are the capability I will need to build to understand that, gain a competitive advantage in that particular skill set. Once you have that, then finding the right course is not anyway difficult, I would say. Pritesh, does this answer your question?
Hello, sir.
Yes, please go ahead.
Yeah, sir. This is Pritesh here. Actually, I'm working as a professor at one of the university in the Department of Mechanical Engineering.
Mhm.
So at our university, we are trying or we are motivating students to make EV vehicles.
Hmm.
So we were wondering that what actually course we can introduce in the curriculum, so it can help students to gain a better knowledge. Although we have a course, but it is not the deep dive knowledge. It does not provide the deep dive knowledge. So is there is any particularly course which is designed or any specific is there so student get better information about that? That was my questions.
Yeah, I think there's a fair question. Actually, you need to understand the components of a EVs and then introduce the hands-on skill development for that particular track. So, for example, I can go and say that you can introduce a course called mobility engineering where people can understand how the different parts of EVs come together to build that EV and work. Okay. you can teach people. It will be an interdisciplinary thing. It will not be a one particular domain specific. You will bring the electronics and electrical knowledge from that side. You will bring the the battery technology knowledge from one side. You need to have the simulation capabilities in that, and then you can build those capabilities individually on that. I think that will become a much more holistic course experience to the candidates rather than just teaching in one particular domain. And obviously, you can definitely build a electric vehicle, small prototype inside your campus. So we think the students can build it. That would be a real hand, understanding of the systems. Why can't we have something like a specialization in BMS, battery management system? Why cannot we have a specialization on motor control unit? Why can't we have a specialization on how the system integration happens in EVs? So those kind of specification I'm looking. If you want a one level more deep down, but in general, how the systems come together and work and integrate with each other, and how that can be developed further, I think should be a great course in itself.
Thank you very much, sir.
Yeah, any other question?
No, sir. Presently, we are not having. Guys, anyone is having any other questions? Yes, I think we don't have any questions, sir.
Yeah, I think if everybody we are done with things, I think there is no question. I think we can close the session. And
Hello, sir.
Yes,
Sir,
Thank you
I
so
do have a
much.
question.
yes,
Hello.
please go ahead.
Sorry to interrupt, sir.
Yeah, sure.
Sir, according to you, sir, the designing perspective is affected by how many percentage while making any brand?
Design of the vehicle you are asking in general?
Yes, yes. I am asking about the automobile vehicle designing.
So design has two parts. One is the appeal on the consumer side, and one is the design that affects your range, performance, and actually the capability of the vehicle. Okay. So if you talk, there are all different perspectives that you have if you approach this problem from the different sides. If you talk from the consumer appeal, which segment you are trying to attack, it has dependency. So if you're trying a millennial segment, which wants a very classic design and which they can differentiate with others, it has a lot of weightage in that. If you talk about design from the vehicle capability perspective, then of course the how the motor and how much speed you can extract, how much juice you can extract out of the battery, all depends on the design that you make for the DV. So that is how the two different things are related. I will say that design has a lot of impact on both the things. Depends on how you want to position the vehicle.
And sir, according to you, what are the main perspectives about learning automobile designing? Like how should a person can learn about automobile designing, sir, vehicle designing?
So vehicle design in general, there are a lot of automobile engineering courses you can do. Even if you're a mechanical engineer, mechanical engineering also covers those courses on how to do. There's a finite element analysis, the computer aided engineering. That is one of the main design and simulation people do. CAD CAM, of course, are there. So you if you do go the route of automobile design or automobile engineering or the mechanical engineering, you will be able to get all these some course somewhere or the other in general. And then of course you do masters and specialize on a particular domain, and then become more capable person on that particular domain.
Okay, so thank you.
Thanks.
Thank you, sir. I think we can end the session.
Yeah, sure.
Thank you, sir. Thank you for your wonderful time. Thank you, candidates.
Bye.
Bye, bye, bye.